movie about how we can start moving things around using NGL. And what I've added to the class is an NGL transformation. And what this does is it encapsulates rotations, translations, and scales using a very basic affine transform matrix. If we look at the NGL source, we'll see that this class has methods to construct it. When it's constructed as the identity matrix, so it does nothing. We then have methods to set scale, to add scale, to set position, to add position, and to set rotation and add rotations. And the rotations are standard Euler rotations around the Cartesian axes. And the final thing that happens is we have this method called compute matrices, and what this does is it sets the transformations in a set order. And again, if you look at the lecture notes, it goes into a lot more detail about this. But you can see that first we set the scale, we create rotation matrices for the x, the y, and the z, and we combine scale with rotation of the x, the y, and the z axis, and finally we set the position. And what this does is it creates these three matrices: normal matrix, the transpose matrix, and the inverse matrix, which we can grab by the accessors. Most of the time, all we want to do is to get the normal matrix, and we can load that directly to the shader if we wish. So, at present in this demo, I'm not using the transformation, and if we run it, you'll see that what happens is we just get the cube as normal, and nothing is changed. So there's the cube there. So if I simply say m transformation dot set position, and I go -4, 0, 0, we should now see that that transformation will move to the left in the x-axis 4 units, and you can see it's moved there. Because of the projection we're using, it looks as though it's rotated slightly. If we were to just look at it in an orthographic projection, it would be slightly different. Now, this is happening because we've made a call to load matrices to shader there. Load matrices to shader is calculating MVP by saying transformation get matrix, multiply that by view, multiply that by projection. So we're getting our correct positioning, projection in the system. And we can do a few more things. So let's set some scale now. So again, transformation dot set scale, and if I do 1 to 1 like that, you should see that we've now scaled in the y-axis, and you'll see that we've now got change there. And if we now do some rotation, let's set rotation. So let's do 45 degrees, 25 degrees, and it will automatically convert from degrees into radians in the calculation, so we're just passing values in degrees. And we can see that we've got some rotation there. We'll also see, because of the way the transform stack works, that if we move things around, it doesn't actually matter. These are default settings. It's always going to give us exactly the same combination of matrices. It's specifically designed to do this. Now, the other thing with this is if I were to do something like this and set the position to like that, I'm loading matrices to shaders again, and then I'm going to draw a second cube. This is going to retain the rotation and the other orientation, as you can see, but it's now changed the position. It's important to remember that we must load matrices to shader each time. So if I run this without loading matrices to shader, two cubes will be drawn, but they'll both be drawn in the same position because we've not updated the transformation on the shader. The MVP is still the persistent one. So this is quite important. And again, we can see that if I, instead of drawing a cube, draw another object. So I want to draw the troll there, which will most probably be quite large compared to the cube now, but you'll see that we're actually getting the two objects being drawn because they're at the same position. We've not loaded them to shader. If I now load the matrices to the shader, we get the new one added there. So this is most probably the simplest way of generating this sort of drawing and everything else using NGL to pass the data values through using the basic transformation.